Hey all you cool cats and kittens. Today I'm here to teach you about fuzzy logic. I know what you're thinking. It's not the fuzz in this stuffed animal. It is the logic of fuzziness. So let's get into it. Fuzzy logic was created in 1965 by the man, the myth, the legend, Lotfi Zadeh, a professor at the University of California at Berkeley. Go Golden Bears. He created it while doing research on fuzzy sets, another idea he created, just an overall genius. Fuzzy logic differs from traditional logic because it is more vague, more broad. It applies degrees of truth rather than being completely true or completely false. In traditional logic, that's exactly how it works. A statement can either be completely true, which you would assign a value of 1 to, or completely false, which you would assign a value of 0 to. In fuzzy logic, you assign values in between 0 and 1. The closer to 1, the higher degree of truth there is to the statement. For example, an example of a traditional logic statement is LeBron James is 6 foot 9 inches tall. Like, that is a true statement. You can't dispute it. It gets a value of 1. But with fuzzy logic, you would use LeBron James is tall. That's very broad, very open ended. But at 6 foot 9 inches, most people would agree he's pretty tall. So you would assign a truth value of, say, zero point 0.8 to that statement instead of just 1, because there are taller people than LeBron James. He is not completely tall, like the tallest person, but he is still very tall, and that is a very close to being an absolute truth. Along with fuzzy logic are fuzzy sets, and these are sets without clear, crisp, defined boundaries. Elements in these sets are only partially in the set to a degree. Compared to traditional sets, elements in those types of sets are either in the set or not. In fuzzy sets, they are in to a degree between 1 and 0. Again, the closer to 1, the closer to being in the set. So, a good example of a fuzzy set would be the set of weekend days, because there's two obvious members, Sunday and Saturday, both completely weekend days, no one's disputing that. But then the boundary becomes a little unclear with Friday. Some people consider it part of the weekend, some people don't. It definitely sort of feels like the weekend once you after school or after work, but you still have to go to school or work where it just feels more like a weekday. And Monday, Tuesday, Wednesday, and Thursday obviously aren't weekend days. So it's a good example because there's just not that clear, crisp boundary. So here we have membership functions, which can show how well elements can fit into a certain fuzzy set. And so on the left is the equation, which is mu sub a times x equals, and then there's the rules on the right. And in this particular one is a piecewise function. And the range is always between 0 and 1. Of course, closer to 1, more true, the closer to being a member it is. And on the right, we have the graph which shows the set, and on the x-axis would be the elements, and on the y-axis it is between 1 and 0. Of course, closer to 1, closer it is to being a member. So membership functions aren't only piecewise triangular membership functions, there's also piecewise trapezoidal, Gaussian, Gaussian-Bell, also sigmoid. There's just a lot more. They can come in many different shapes, and these are just a couple. Fuzzy logic today is used in many different products, from microwaves and vacuum cleaners to computers and artificial intelligence. It's used to adapt to different conditions, such as a vacuum cleaner being stronger when it detects more dirt in an area. So we're going to end with a true, false, or in-between quiz really quickly. First statement, fuzzy logic was created by Lotfi A. Zadeh, professor at the University of Stanford in 1965. Second, Usain Bolt is fast would be an example of a fuzzy logic statement. Third, many products we use today incorporate fuzzy logic into them, such as microwaves and computers. And fourth, Friday is in the set of weekend days. 1 is false because he was a professor at Cal Berkeley. 2 and 3 are true. Then 4 is a fuzzy statement with, in my opinion, a degree of 0.5 because it can both be considered a weekday and a weekend day. Thanks for watching.